In this video, we're going to expand upon the Dynamo player graph that we converted from an existing Dynamo graph and convert that to work with generative design. We're going to add additional nodes to the graph, dictionaries, outputs, and a fitness function. Since this video will be a little bit longer, we have chapters below for each portion of the graph for you to be able to jump around and learn all the techniques involved with converting an existing Dynamo graph for use in generative design. In addition to the chapters, we have the sample files linked below. This includes the beginner graph, so the beginning of the Dynamo graph from the Dynamo player workflow, all the way up to the completed Dynamo graph for generative design with all of the nodes added. You can use the completed one to follow along with this video if you'd like, or you can build it from scratch from the beginner graph. That in mind, let's go ahead and open up the beginning Dynamo graph to get started. So this is where we left off. We had the graph for Dynamo Player with inputs. These are all marked as inputs under the right-click menu. And we have the randomization of planting instances that we pick within Revit. So in order to get started here, we'll notice that the family instance by point is currently placing family instances. That's something we don't want to happen every time a generative design graph runs. So we need to prevent that from running. We have a few options here. We can freeze this node, or we can go ahead and navigate to the generative design menu item, data, and use a node called gate. Gate is a really nice node because it allows us to block that creation of those elements by leaving this closed. This gate node is really special, and we'll go ahead and press run because those have not been created. It is able to be opened within the generative design menu, and we'll see that here in a little bit. So we're going to get that placed. We'll go ahead and add the gate to this group. So we'll go to groups, add to group, and typically we'll use a purple color for our gate nodes. And I'll use the lighter purple actually. Go ahead and click save. And the next thing that we're going to do is we're going to navigate to extensions, graph status, and this is a section where we can tell the graph that it is for generative design. At this point, we will start to get prompts for what the graph needs in order to make this work in generative design. At this time, we don't have any outputs. The original graph for Dynamo Player had an output to show which family instances were created, but we don't need that one because we need to create a fitness function in order to make this work with generative design. For our fitness function, we're going to end up evaluating the surface area that's covered given a certain amount of plants. So in order to create our fitness function, we're going to go ahead and start by right-clicking and searching for a watch node. This will be our output, so we can go ahead and right-click on it and say is output. All these errors will update live for us to be able to see what's going on. In this case, it will be coverage percentage. We'll click accept. We'll hit run just to refresh. And there are no values in this node at this time, so we still have an error. We're going to leave this over to the right because we need to create some additional portions of our graph in order to start to use that. I mentioned that we're going to use the coverage area. This is a surface in Revit and Dynamo, so we can go ahead and extract the area from that. In Dynamo, if we navigate to geometry, surfaces, surface, we will see all the options available to us. Under the query section with the question mark, we have an area node. Let's go ahead and place that now, and we'll connect our initial surface area to that node. If we go ahead and connect this to our coverage percentage, the generative design graph status portion will start to prompt us that we're missing a few items. In generative design, there is a concept of having to cache geometry for it to run. If we zoom in on this red wire, we will see a plus sign. Clicking on this plus sign adds another node called a remember node. This allows us to cache geometry for it to be able to be used in generative design. If you don't know, generative design uses several Dynamo instances in the background to run Dynamo workflows. So it's running several instances of Dynamo in the background for you, which is really awesome because we can create these workflows with a lot of runs very quickly. We will notice that the remember node only connected one output at this time. So I'm going to go ahead and drag this additional output into the other surface input. And for now, I'm going to disable the preview of this remember node since I am feeding geometry into it. I'm going to press run, and we'll see that our surface has been cached and we're good to go. For remember nodes, we typically use a group that is purple. So I'll go ahead and create a group. We'll make it a light purple. And I like to put the word cache, and we'll say cache surface geometry. You can make these groups titled as long or as short as you'd like. Press run just to make sure that's all refreshed and we're good to go there. Now's a good time to save. We will get this little dialog that says that we have issues at this time. That's okay because we're not ready to go into generative design quite yet. Additionally, for our Dynamo player workflow, our randomization used element types. These work really well. However, for generative design, we need to use another strategy called dictionaries. Dictionaries are really great ways to look elements up from a lookup table to reuse them. In generative design, this is kind of a trial and error situation to where it will start to tell you that you need to remove these items from a loop and things like that. In this video, I don't really want you to get stuck in that loop, so we will just break this down for you to be able to use this strategy in future graphs as well. Dictionaries are available in the Dynamo library under the Dictionary category. Under the Create subcategory of the Dictionary category, we have an option to create a dictionary by keys and values. In this case, a key is a string and values can be a list of items for us to reuse. This is really, really nice to be able to use it in this way. In this case, I know that I want to allow my user to pick planting instances. I want to get the ID of those instances and use that as my key for my dictionary. If we right click and search for a node called unique ID, we will see that that's available to us in the out of the box nodes. If we connect unique ID to our planting instances and press run, we will see that we have really long IDs for these planting instances. Unique ID is really nice because it is going to be different per element and it allows us to look up elements based on that string. So we'll go ahead and use that. We'll plug this into our keys. We'll tidy up our nodes a little bit here. Press run, and we'll see that that has now fulfilled that first input. For our next input, we want to serialize a few different pieces of data from the selected planting instances. These are going to be things like the geometry, the location, and the overall bounding box of the geometry. That's going to allow us to create our fitness function that analyzes how much of the surface is covered. In Revit, these planting objects are actually mesh elements. Meshes are a bit difficult to work with in Dynamo, but we are able to use these in a way that works with generative design. It does require a few additional nodes, and those are included in the dataset as well. We're using a package called Mesh Toolkit for this, along with another package called Spring Nodes to convert between the different types. This allows for a really great visualization in the viewport, and installing the packages is worth it, especially with the result that we get. So back in Dynamo, we need to extract a few things from these instances. In this case, if we were to navigate to the Revit category, the Elements subcategory, and the Element subcategory, we'll see all the options available to us. We can get all the geometry associated with an object, so we'll place that node now. We can get the location like I mentioned, and we are also able to get the bounding box of the element as well. So all of these are things that are going to help with building this geometry preview in our window for generative design. Holding down Control on our keyboard and clicking on an input allows us to duplicate it. So I'm going to duplicate that element input 3 times into these new nodes, and we'll press run. As you can see in our background, the planting that I previously selected is available to me, and I see that in the background preview. All these nodes interact with that geometry for me. So we'll see the locations being selected, the bounding box, and the geometry. The geometry returns sublists, so we will need to flatten that list because we don't want to have sublists in this case. We want to have single lists, one flat list at the end. So I'm going to search for a node called flatten. We'll plug this in. clean this up a little bit. And we flattened out those mesh objects. Something I tend to do is as I interact with geometry nodes, I'll hide the geometry that I know that I don't want to see as I'm working through the graph. In this case, I don't want to see the mesh and I don't want to see the location either. Awesome. So that's good to go there. So we'll go ahead and hit save just to save the graph as we're working. And we want to have all of these values available to us in our dictionary. The easiest way to do this is to combine all these into a list and then flip that list to where they're sublists. It's kind of confusing to begin with, but we'll break it down now. Right click and we search for create. We will find a node called list create. It's about the 5th node down for you. With list create, you click on the plus sign to add more inputs to combine the lists. We'll combine all 3 of these lists together with the list create node. And now you'll see that all of our meshes, points, and bounding boxes are combined together. These don't represent the individual instances at this time because they're combined with like elements. In order to make these sublists that apply to the actual elements, we need to transpose this list. So if we right click and search for transpose, this will flip these lists to where they make a little bit more sense. In this case, this mesh, this point, and this bounding box belongs to this first plant, and so on. So this is how you start to combine those things in a really nice way. A lot of people call this topic weaving list, to where we weave them together. So that's a good way to think of it as well. And now we have individual sublists. We have 7 sublists, so 0 through 6, that apply through the 0 through 6 of the unique IDs. We can plug this into our values and hit run. And we now have a dictionary that's working by those keys and values. Really nice workflow right here to serialize all this geometry to reuse it throughout a generative design graph. I'll go ahead and clean this up a little bit. And we're going to go ahead and group all of this together. This is a pretty big action, so I'm going to go ahead and group this as a green group. And we'll say serialize geometry for lookup. And I'll just leave the description clear for now. And we can go ahead and save. We will keep getting this warning because we aren't quite done converting it yet. So we can just kind of ignore that and hit save. Now you'll see that we have our dictionary available to us. Previously, in Dynamo Player, we had the randomization working with element type. That's not going to work for this workflow, so we will end up dropping out this element type at this time. So I'll go ahead and right click on this and say remove from group. We'll keep that for now, but what we want to replace this with is the unique ID. So if I plug the unique ID into the list cycle and hit run, we will see that we have 61 unique IDs available to us. This is really useful because we are able to use this to get those values from our dictionary. In Dynamo, under the dictionary category, we have a node called value at key. This allows us to input a dictionary element and a key, which would be our unique ID, and retrieve values. And now you'll see that we have the mesh, the point, and the bounding box for each one of our unique IDs. This is really nice because I can use this to now generate my elements on my surface. I'll go ahead and disable the preview on this and any of the additional portions where that showed up, just so that way we can only see what we're building. Awesome. So now as we hit run, we are retrieving those exact elements from that dictionary. And here's kind of what we have so far. All right, in order to preview the mesh, we need to move this mesh from the origin onto the surface. The easiest way to do this is to use a package called Mesh Toolkit. This allows us to convert the mesh to something that is movable in a really great way. So what we can do is back where we're extracting our mesh elements, which is going to be right here at this list flatten, we can go ahead and convert this to a toolkit mesh. In order to convert it to a toolkit mesh, we have to use an additional package called Spring Nodes. So if we search for TK Mesh, there's a few different options in here for us. In this case, we're converting from a Dynamo mesh to a toolkit mesh. So we'll place that node now. We'll press run, and we'll see that we still have a preview in the background preview available to us. I'll go ahead and disable the preview and press run again. And we now have toolkit meshes as the element in our dictionary. This is important because under mesh toolkit, mesh category, we have a few options in here for us. We have an option in here to translate a mesh from one location to another. In this case, we want to translate it from the origin of the plants, which are all over the left side of my building, to my surface. So that's kind of where this comes into play. If we place the translate node, we will see that it takes a mesh and a vector. Awesome. So the first thing we need to do is get the mesh from our dictionary. These are the first item in the dictionary. So we can do this with a get item at index node. So we'll search for get item at index. We'll plug our dictionary into it, and we want to get that first item. The easiest way to enter numbers in Dynamo is just to double click for something called a code block, type in a number, and you now have a number node as an output. Don't let the word code block scare you too much. It's a really easy way to interact with Dynamo and do shorthand for some of these interactions. By default, we are going to get the first element on this outer portion of that sublist from the dictionary values. That's because we are working on that outer side of this. We want to actually work one more level in. The way we do this is we click on the little chevron icon on the list input and select use levels. And when we press run, we'll see that we extract all the meshes from that dictionary output. That's called working with levels. More information on working with levels in Dynamo is available in the Dynamo Learn videos, and we'll also link those below. So now we have our meshes extracted. I'm going to go ahead and right click and disable the preview because I don't want to see them in the background. And we now need to move these around. In this case, that would be our mesh that we want to move. And then our vector we need to develop now. If you recall, in our dictionary, we do have the points stored for us. So what we can do is we can actually copy this get item at index. We'll add another line for the second element, which is index 1. And if we press run, we will see that we now have points, which is really cool. In order to build a vector, we'll go ahead and navigate to the geometry category in the library. So under geometry, abstract, vector, we have a few options available to us. One of the options is to create a vector by 2 points. Let's go ahead and place this node now. Where we want to end the vector would be where the ultimate location would be, and that's on our surface. So that will be our end. Our start is where the mesh element started at, and that's over in the back corner of our Dynamo graph. If I toggle the preview for this get item at index, we will see those points over in the distance. I'm going to disable the preview, and we're good to go. For our endpoint of our vector, that's going to be the points on our surface. Those occur at this point at parameter node up here in our green portion of our graph. So we're going to connect that now as well. We'll just clean up our nodes a little. And now we have vectors developed. Vectors are a geometry type in Dynamo that doesn't have a background preview, so we can just leave this node alone. Connecting the vector into the mesh translate node, we can press run. And we now see that we have all of our different plants showing in the preview in a really nice way. Once again, there is a little bit more work for this since they are mesh elements, but I think it's worth it because this preview will really help us in generative design to explain and tell the story of what we're trying to achieve. We'll go ahead and press save. We'll do save with issues for now once again, and we can continue from here. In this case, I know that my fitness function is something I'll have to build upon here in a little bit. So I'm going to drag this over to the right, and we'll go ahead and start cleaning up and grouping these nodes as well. So now we have that. We'll group this. Control G on your keyboard will create a group, and we'll make it a lighter green. And we'll go ahead and title this extract because we're extracting data from the dictionary. We'll hit save once again. And if you don't want to see that warning while you're working, you can go ahead and just navigate and click none for the graph type. And now those warnings won't happen anymore. So that's an option available to you. We'll go ahead and reopen this graph status here in a little bit. So now we have our mesh showing. In order to preview this mesh in a nicer way, under Mesh Toolkit, we have a few options available to us. If we navigate to Mesh Toolkit, Mesh, there is an additional section in here called Mesh Display. If we place the By Mesh color node, we will notice that it takes an input mesh and it takes colors to be able to color code the mesh as well. In Dynamo, if we search for color palette, we have a really nice node that allows us to pick different colors in a really great way in a UI. I'll pick a green because planting is green typically. We'll toggle the preview of our translate off and we'll hit run. It'll think for a moment, and now we have a really nice preview in our viewport. We're going to create a group with these as well, so Control G for group. I typically make these displays blue. We'll title it Visualize, and we'll say Results as the description. So now it's a really nice visualization node that will show in Generative Design as well. Go ahead and click Save. And now the next portion of our graph, we need to create our fitness function to actually show what the coverage percentage is. In order to do this, we want to use these bounding boxes that come from our dictionary. This gives an overall representation of the coverage area of the planting. So we can go ahead and do is we'll copy this get item at index. I'm going to do a new code block by double clicking and put that as index 2. We'll hit run and we'll see that our bounding boxes are now getting output as well. Bounding boxes in Dynamo don't really have geometry to them, so we have to convert these to something else. In this case, we want to convert them to cuboids. So if I hook bounding box in, we'll see cuboids show up in the background preview. You will notice that those cuboids are off in the distance, and that's because they're representing the current location of the bounding boxes, which are all around our building at this time. So we will need to move these just like we moved the meshes above as well. So the easiest way to do this is to translate these using the same vector. So if I search for a node called translate, we will see that we have several options available to us. In this case, there is one in here for geometry. So if we hover, we'll see the different variations of this. This one right here has geometry as our input and the direction vector as our other input. So we'll place that node now, hook our geometry and our direction, and when we press run, we'll see all the cuboids move to the surface. We can disable the preview of the ones off in the distance, and we're also going to disable the preview of the ones on the surface. This is for our fitness function, so we don't really need to see them. You could do your visualization with these cuboids instead of the meshes as well. So there's a few options there. In this case, I need these to be all one solid. So in order to combine solids in Dynamo, we have a really great node called by union, and it takes input solids and it will output one whole solid. This is really important when you're interacting with these options to subtract things from a surface because one solid will work way more stable than several. So that's kind of the easy way to handle that. Go ahead and drag that to clean that up a bit. And now we just need to subtract this solid from our surface. Earlier, we drug this off to the right, our surface area and our coverage percentage. This is the portion of the graph that's going to be our fitness function. So we can start to interact with this now as well. In this case, we are working with a surface. So if we were to navigate to geometry, surfaces, surface, there are options available to us. And here we do want to subtract things from this surface. There is an option, subtract from, that allows us to subtract solids from a surface. Let's place this node now. In Dynamo, if we hold down Control, we can duplicate input ports. So I'll hold down Control, plug this surface into this surface node, and then I'll take a solid and make that my trimming entity. Pressing run, it will complete that action for us, and it doesn't really look like anything happened at this time, and that's because our preview needs adjusted. I'll go ahead and disable this solid preview, and way back at the beginning, we need to disable the surface preview of the selection node. And now we'll see that we have a surface area that represents all of the uncovered space at this time. So we can kind of look at this a few different ways. We can analyze our fitness function for the percent covered or the percent uncovered. In this case, we'll go ahead and make it for our percentage that is covered. So in order to do this, we're going to go ahead and flatten our output because we just want one surface element in this whole thing. So we'll flatten that. We'll disable the preview for the previous one. And now we can hold down Control and duplicate our surface area node to get the new surface area for the uncovered portion. And then we can take these areas, and I'll actually stack them in the way that they happen, and divide those out. So in this case, we'll see that our surface area that's uncovered is 35%, so 0.35. In this case, if we want to get the covered percentage, we can go ahead and do some math in a code block. What I'm going to go ahead and do is we'll do parenthesis 1 minus uncovered. We're going to multiply this whole thing times 100 to get an even percentage number that's recognizable to our end user. I'll press run, and we'll see that we have a coverage of 64.5. In Generative Design, it will show that whole decimal value, so we do want to round this just to make it a little bit cleaner for our end user. If we search for round inside of the search menu, we will see that there are a few different options for us. There's an option in here that is round, and it includes digits. That's the one that we want to use. So round, and the inputs are number and digits. So we'll input our number. I'll use the same code block. Click after the semicolon and we'll type in 2. And now we can get a nice round number that represents our percentage covered. You will notice that there is a 0 in front of the 64.59 in my case. And that's because it's coming out as a list. In Generative Design, if we go ahead and connect this to our output node, we will see that we also have a list. If we go back to graph status, we make this a Generative Design graph, we will see that that coverage percentage is not liking that value. And that's because it doesn't want a list. It wants a single value. Easiest way to handle this is to search for a node called first item. We'll place this node now, and we'll connect this and hit run. And that should mitigate that issue. So at this time, our output is now working, and it's working in a really nice way. However, we do have a few other errors. But at this time, our fitness function is complete. All of these nodes comprise our fitness function for Generative Design. So we're going to go ahead and select them all, press Ctrl G on our keyboard, and we'll make this an orange color to indicate that it's some kind of function. We'll call this fitness function, and we'll add the description as get coverage percentage. And we have our fitness function. Once again, we re-enabled the graph status for Generative Design, so hitting save will give us this warning at this time. But we want to save in order not to lose our work. So we have a few more errors occurring in our graph at this time. So as you can see, all these red wires are telling us that we need more of these remember nodes. So these remember nodes need to cache things for us. And you'll see that there are a few being suggested to us. So in this case, I need to cache the unique ID of my instances. So I'll click plus to add that one. Dragging it into the group will add it to a group. I'll reuse that same one for the keys here. And we have that one complete. We also need to cache the mesh of the tree elements or the shrubs. So I'll go ahead and hit plus on that one. Clicking on it and dragging in the group will allow us to add that to the group. This will show in the background preview, so we want to disable the preview of that. We need to cache the location of the element. That will also show in the preview, so we want to disable that one as well. And we also need to cache the bounding box. This is interesting because Generative Design will suggest to cache this, so if I hit on the plus sign, we're good to go. But when I press run, it's still going to tell me that something's going on. And that's because the remember node can't cache a bounding box. So later on in our graph, we convert that to a cuboid. So what we need to do is actually remove this cuboid and use this earlier in the graph. So I'll go ahead and just break this connection. We'll right click on this cuboid node and say remove from group, and we'll actually move this before that remember node. So it's a little bit confusing, but it is something that you just need to keep in mind. And I want you to be able to know that this happens. That way, if you run into it, you are ready. So I'm going to hit run. And now our graph will work. We have no issues, and our cuboids are visible in the background. So we will have to disable that preview as well. It's one of those things that I could have just not mentioned that, but I want you as a user to know that that exists and that you need to account for it. So that's one thing that I want you to take away from this lesson, is that you do need to consider some of these things. And sometimes you need to kind of experiment with your graph a bit. I'm going to click run. And now as we hit save, we won't be getting any issues with our graph. So we've added a few nodes. These groups here at the bottom are the new ones. We can take out this element type node now. We'll hit save and run, and we're good to go. So as we change our sliders, let's change our density a bit and hit run. We will see the graph update live, and the surface area is updating as well. Really, really cool. This is ready to go. For our gate node, we also need to add a few more bits of data to this. At this time, we are inputting the unique ID of our instances into the gate node. We need to actually modify this to get the family type for us to be able to use when we open this gate node in Generative Design. Under the Revit category and the selection subcategory, there are a few different options available to us. One of the options that we want to use is the element by ID option. This allows us to get the element from Revit based on the unique ID or element ID. In this case, that will be the element instance. So if I hit run, we will see that replicated. We need to convert this to the family type. I'll just search for a node called element type. And it's the third option. And it says that it returns the element type for this element. We'll place this node. We'll make our connections. And now we can add these two nodes to our group as well. That's kind of the conversion that we want to be able to get the family type for our gate node to function as intended. So as you can see, we have this marked as a generative design graph. If we go to extensions, graph properties, we will see that the description, the thumbnail, the author name, and the learn more URL carried over from Dynamo Player as well. This is all fine. I'll leave this for now. Going to hit save one more time. And now we'll navigate to Generative Design in Revit. So under the Manage tab, the Generative Design panel, we can go to Create Study. In this case, I have my workflow saved on my desktop in a folder that I created called Dynamo. As a reminder, you can add more folders to this if you'd like by clicking on the Add Folder icon and adding your path here. In this case, my graph is still called the Begin title. You can change this, of course. I suggest you change it if you're going to use this graph, but I left it begin for now. We're going to click on the graph to be able to modify our inputs. Let's take a look at what all is happening in Generative Design now. So as you can see, all of our inputs stayed. All that stuff is just cached within the file, but you can change your selections as well. So for the host face, that's already pre-selected for us, which is fine. We can kind of ensure that it's the right host face, which it is. Our planting instances are all the ones around the building. The density stayed as well. The amount of plants is available in here. By default, it is checked, but I changed it to be 50 as a hard value. And the coverage percentage is what we're going to optimize. So in this case, I want to maximize how much the coverage is while staying within this 50 constraint. So it's really interesting to be able to do with generative design. I can throw 50 plants at it and say, give me options that work to cover the most area because I know I can get 50 plants ordered or whatever. So that's kind of the default there. Clicking on the three dots in the upper right-hand corner allows it to save default settings. So I always recommend to save default settings when you find some that you like. I typically leave the population size and the generations the same. The generative primer has a breakdown on what these values mean, so I encourage you to check that out. We'll link that below as well. And with that in mind, we're able to start to click generate to generate some options. While generative design is running, you are able to preview the results really quickly in the viewport. As you can see, we have all of our trees showing at this time, and we are on our first run of 10. So it's really cool. You can actually click on these and interact with it while it's running. So I encourage you to do that as generative design is running in the background as well. So there we have it. That's kind of interesting. I kind of like how that's spread out actually at this time. With an optimization run though, it's going to keep optimizing to maximize that value that we picked. So let's go ahead and let this run and we'll see what else it comes up with. Once generative design is done running, we are able to preview the result that it optimized against. Note, we did do this as a single objective optimization for the coverage area. So next steps to this graph would be to add other fitness functions like cost or things like that. That's another option available to you, and that would generate more results. This is kind of that beginner conversion to convert this to an initial generative design graph. So I encourage you to explore this example further. In the viewport, we can scroll around and kind of see what it came up with. And it's pretty nice. It's a pretty nice preview. We have those 50 plants. They're spaced pretty wildly all over, but we have a really good coverage. We ended up landing at 71.6 for the coverage, which is pretty cool. You can also try this graph on just a randomization workflow, and you'd have a ton of results to choose from. It is better to run this on optimization and add more fitness functions though, so something to keep in mind. So with this complete, we can go ahead and create the elements now in Revit. Remember earlier when we placed that gate node to block the family creation? Clicking on the Create Revit Elements button allows us to open that gate node in the background to create those elements. So let's do that now. All right, now we have elements created from generative design. So you can see all of our family types are placed. They're all placed very much like they look in the viewport. We actually can see that we have that one shrub off in the back corner. That's right here in this back corner as well. So there we have it. That's how you convert a graph from Dynamo Player to generative design. I encourage you to take this graph, add a few more fitness functions to it, change up the inputs, things like that, and see what you can come up with. It is a process to convert an existing graph to generative design, but it is very worth it because you can add a lot of data to this process and start to really augment your workflow in a great way. Let us know down below if you have any comments or ideas or anything like that, or if you build something else with this graph or workflow. And thanks for checking out this video, and good luck changing all your graphs over to work with generative design.